This was actually the very first day, well, it's only the second day of our stream, where I could get some lunch. I tried my very best to manage it because it had only like 20 minutes or so. But we are back on the live stream, still in Hall 2 of CeBIT 2015 at the Intel booth, the TechLounge studio, live from Hanover. We're going to talk about smart grids, and I'm so glad to have a guest over here, Hannes Schwaderer, Managing Director at Intel. Hannes, you joined us also last year, and we've been also talking about smart grids.
Yep, you cannot talk about it more than enough.
You know, I mean, it is in general also when we look back at the last 3 or 4 years of CeBIT, how the cloud came up and how the Internet of Things came up. It is just perfectly embedded right now, the topic smart grids, in the environment of CeBIT. And you see so many companies, suppliers that are actually working towards the idea of a smart grid. So it seems finally that it's taking off and it's just settled in the market space.
Yeah, it is taking off. I mean, when we talked last year, we were talking about piloting this, piloting that, trying new things, try to develop business model solutions around our technology. How can technology help? In the meantime, we have two things. First of all, we have a very clear picture of what's the business case by digitizing an old infrastructure.
Yeah.
The technical need gets bigger and bigger every day, and we now have real implementation, so we can prove there is a benefit, there is a business opportunity in digitizing this infrastructure, because the benefits are so big that the investment seems to be minute relative to the benefit of it. So it becomes more concrete, more players engage, new players come to the market, so this is an extremely lively marketplace.
So when we're talking about the smart grid, just as a wrap up again, before we even starting, we're talking, of course, about more energy efficient grids for the future. We're talking a lot about saving energy. We're talking a lot about saving money by setting up new infrastructures. And as you said already, the biggest challenge is to create this, or to make this digital transformation of an infrastructure that's been around for decades, if not almost for a century.
Actually, the electric grid in Europe as it is today, defined by 220 volt, 50 hertz was defined in 1887, so it's a pretty old infrastructure and it's still working. What has changed is that this grid was defined as a tops-down network.
Yeah.
So we generate at the top and we consume at the bottom, and we had transformation, high voltage, medium voltage, low voltage in the middle. Mm-hmm. This is a one-way stream. It used to be a one-way stream. Now with renewable resources like solar panels, wind turbines, geothermal energy, we become a feed-in system where we feed in electricity at every voltage level.
Yeah.
Now you can imagine what happens when you have a water pipe and all of a sudden you pull more water in the same pipe, it starts to explode. Yeah. And at times where we have a sunny day like today, cool weather, then the solar panels are more efficient. At some points we see that the electric current turns around and flows upstream, and too much energy is as bad as too little, so it causes clashes in the infrastructure, in the worst case blackouts. So this is the situation that hasn't changed. It just gets worse or better every day, the way you want to look at it. Better because long term we want all the renewable energy in our grid, but shorter term it causes massive challenges in managing these energy streams. That's where we started. That's where we now have developed concrete solutions. So we are piloting currently 100 medium to low voltage transformers. We put in a standard industry PCE. We developed some sensing technology that can take in a range of 900 data points at any point in time. And we aggregate these data into a very small signal that goes directly into the control room of an electricity company. So now for the first time, they have transparency as to what is happening in the last mile.
Yeah.
Now that's easy, relatively easy with 100 of these stations, but only in Germany we have about 860,000 of these stations, and no human eye can control what's happening in 860,000 substations. So the next level of build out is that we put into an analysis engine. It's kind of a big data analytics application basically that simulates what would happen if and then gives a recommendation to the control room. They should switch on and off power, right? Basically to stabilize the grid. Now, this is an obvious use case, but you said this is for saving energy to a certain extent, but I would take that as the second priority.
Mm-hmm.
The people we work with are energy companies. It's not in their biggest interest to save energy. It's like a drug dealer telling his customers, take less drugs. Right? So that's not extremely good business value. The business value is more in the saving of cost. So imagine we could predict pretty precisely how much energy is being consumed and where in 48 hours from now.
Yeah.
And the same for how much is being generated by millions of solar panels and where.
Yeah.
This would allow us to manage our system, entire system, with a certain outlook. So means two things. It's mainly a business model, first of all. The business model in two ways. First of all, if I knew precisely what capacities I need, where and when, that would reduce my generation cost. So one or the other power plant, I don't even switch on because I know I don't need them. Today, we switch them on because we might need them.
Yeah.
And the electricity we generate is spare, so we give it away for free, more or less. This is not a good business model. So on the operational side, we save cost in the generation of electricity. We burn less fuel, we burn less gas, so that's also good for the environment. And on the same side, if we had a precise information as to where the capacities are needed and when, this would reduce the cost of the build-out of the electric grid dramatically, because I have the security, I know what I'm planning.
Right.
So this total view from both sides makes it a business case. And that's why distribution companies, first of all, are truly investing in finding technologies that help them do two things: stabilize their grid and stabilize the price for electricity.
So you've been talking already, for the very first time, it's actually possible to collect all this data from the very last mile. The way we could collect data before was basically just looking at the meter, right? And saying how much electricity could I actually needed and used over there. But in between there was just nothing. And now with all of these different analytic points and marks and peaks that I can get, those energy companies can very specifically and very precisely work out and figure out which household, which part of the city has its peaks at which time, and where I can actually deliver the energy they need in the best way and also in the most efficient way.
Exactly, and what is not possible today in the old grid infrastructure is that you balance supply and demand in a timely fashion, but also by location. So now we can handle at the same voltage level. There's a little bit too much here, a little bit too little there, so I move it on the same voltage level. In the old technology, you have to transform back into high voltage, transport it, transform down to low voltage, and each time you lose
energy, right?
That makes it expensive.
Yeah.
So it's all starts with transparency. Transparency starts with measuring. We need sensors that take out the data. We need gateways that deliver the data to a backend infrastructure through the cloud. We need applications that then make intelligence from data. That's what we call big data analytics. And then we need the actuation, playing back the information that was data before, is information now, through simulation into the system. And longer term, I see that working as, say, like the internet. A self-managed, a self-maintained system that manages its capacities. You don't have to tell the internet that you are now about to download a movie and it should give you more capacity. That's self-managed. Load balancing is already completely automated in the internet. And that's exactly the vision how an electric grid will look at some point.
I think this was actually the smartest definition of a smart grid that I've ever heard, because it is that simple, well, at least the goal that we want to achieve in the future.
It is a little bit more complex because through the internet we only send electrons. And now we send electrons in two ways, data and electricity, and you need to match these two networks, so it's a little bit more complicated. And it also requires a lot of data points. The interesting thing about big data analytics is the more data points you have, the better gets your prediction. We measure now out of substations. In the future, we will measure out of wind turbines, out of solar panels, so we get more data. If we match these data with historic use patterns, with real-time data, if we combine them with weather data, if we combine them with the pricing at the stock market, we get a possibly best prediction mechanism, and the more data we have, the better it gets. So an interesting business for Intel, obviously, because these data need to be processed. That's cool. But I think most of all, it's for basically every economy, it is important to stabilize their prices for electricity and stabilize their grid, because electricity is the backbone of our society.
Very, very interesting. Smart cities, smart homes, all smart infrastructures are going to be founded and established on smart grids in the future. Hannes Schwaderer, thank you so much for giving us another insight of the future of our grids that are turning into smart grids, and the future somehow, and a little bit of an idea what we can really do with this buzzword of big data. So we're going to have a short break right now. And at 2:30, we're going to be back with Dr. Dieter Kwasnicka from the Technical University of Vienna. We're talking about their science cluster over there. And right now, Chippy is taking a look at the new Hewlett-Packard docking station for roughly about 10 minutes or so. And then we're going to be back here live from the Tech Lounge.